Hi, this is Matt with Fully Silent PCs. This time I am testing the SilverStone HE02 Fanless CPU cooler. The HE02 is designed for Intel or AMD processors and is made of a copper base, 6 heat pipes, and 30 aluminum fins. It is 160 millimeters tall and has a mass of nearly 1 kilogram. The cooler has an asymmetric design that can allow it to fit into small cases, avoid blocking the first PCIe slot on the motherboard, and/or avoid interfering with tall memory heat spreaders. It can be fitted with two 120mm fans, although since I build fully silent PCs, I will not be adding any fans to it. SilverStone claims that the HE02 can cool up to 95 watts fanlessly, though I will be testing that claim here. The real-world cooling capacity will depend on several different things, including the case chosen, the contact between the CPU die and the heat spreader, the contact between the CPU heat spreader and cooler, and the ambient temperature in the room that it is placed in. I paired it with the SilverStone Lucid LD03, which has a sideways motherboard layout and plenty of openings to promote unrestricted natural passive airflow. The fans were removed from the case, as well as any dust filters that might have restricted airflow. My own testing showed the LD03 to perform in this way similar to an open-air setup, which is as good as it gets for passive cooling. For testing, I also chose to use the Gigabyte H370N Mini ITX motherboard, Intel i9 9900 and i3 9100 processors, 16 GB of T-Force Vulcan Z memory from Team Group, a 1TB Crucial P1 NVMe solid-state drive, and a SilverStone Nightjar NJ450 fanless power supply. The build process was documented in my previous video, which you can view by clicking on the suggested video at the top right corner. The ambient room temperature for these tests was about 70 degrees Fahrenheit or 22 degrees Celsius. Thermal Grizzly Cryonaut thermal paste was used between the CPU and cooler. My test procedure included running Prime 95's torture test with small FFTs for half an hour while recording the core temperatures and core power use with Hardware Info 64. I did this a total of 14 times, waiting for the CPU to completely cool between iterations. I started with all CPU power limits set to 10 watts in gigabytes UEFI, and increased power limits each time by 10 watts until I ran into some kind of thermal throttling for both the i9 and i3 CPUs. I did not have any AMD processors on hand to test, and AMD's UEFI settings do not allow for as much control over power limits, but results should be applicable to AMD CPUs nevertheless. I plotted the average core temperature against time. Starting with the i9 CPU, the 30-minute CPU temperatures went up an average of 8.7 degrees Celsius for each 10-watt increase in power use. These power values for each curve are the average actual power use during the tests, not the power limits set in UEFI. Using 80-watt power limits, at the 15-minute mark the motherboard's VRM MOSFETs actually began to thermally throttle, though a couple of the cores were very close to throttling as well, so I knew this was above the cooler's limit and I stopped the i9 test here. Moving on to the i3, the 30-minute CPU temperatures went up an average of almost exactly 10 degrees Celsius for each 10-watt increase in power use. Something interesting happened here. Two of the i3's cores were reading 5 to 8 degrees hotter than the other two, and one of the cores began throttling at 21 minutes during the 60-watt power limit test. I kept the test going as the throttling was not severe, and two of the cores never throttled even at the 30-minute mark. So the i9 made it to the 80-watt test, while the i3 only made it to the 60-watt test. This was unexpected, although I believe I know what caused this difference. Intel's i9 CPUs have solder between the die and heat spreader, while the i3 CPUs have thermal paste there instead. Solder is much more thermally conductive than any thermal paste. Most of Intel's 9th generation i5, i7, and i9 CPUs include solder, but their i3, Pentium, and Celeron CPUs still include thermal paste. You might think that a cooler that is able to cool an i9 9900 at 70 watts would have no problem with an i3 at 60 watts, but that turned out not to be the case. We can blame Intel for that, and not SilverStone or any other cooler company. I've heard it said that certain low-performance coolers should only be used with less expensive CPUs. But what really matters is the power use and the die-to-heat spreader interface. The optimal CPUs for this cooler wouldn't actually be an i3, but a soldered i5 or i7 CPU. I then decided to take a more scientific approach to finding the true passive limits of the HE02. So I plotted the 30-minute average core temperatures against the sustained power use during each test, and calculated the formulas for a linear trend line for each CPU. For the i3 9100, the expected stress temperature in Celsius is 0.98 times the power use plus 38. For the i9 9900, and I assume other soldered CPUs as well, the expected stress temperature is 0.85 times the power use plus 33. The R-squared value for both trend lines was above 0.99. If we target a maximum stressed temperature of 100 degrees, we get a power target of 63 watts for the i3, or 79 watts for the i9. If you are concerned about performance loss while applying a CPU power limit, I also performed Passmark's CPU Mark performance test after each iteration of Prime 95. For the i3, at a safe 50 watts, the CPU mark was 9149, and for the i9, at 70 watts, the CPU mark was 16442. For comparison, I plotted the CPU mark scores against the power limits applied. The i3's performance flatlined after 40 watts, but the i9's performance kept increasing and would most likely continue to increase with higher power limits. That means that you won't get the most out of an i9 9900 with power limits applied, as appropriate for passive cooling with the HE02. Again, an i5 or i7 would be more appropriate for this configuration. So, is SilverStone's recommendation of 95 watts too high? Yes, in my opinion, CPU TDP should not be higher than 65 watts when using this cooler passively. Yes, you can and should use power limits when available, but there would be little reason to use a 95 watt CPU and limit power to 80 watts or less. For the average CPU, I would put a reasonable limit at 70 watts, right between the i3 result and i9 result. If you use a different case that is not as passive cooling friendly as the LD03, the recommended power limit might be even lower. That said, there are not a lot of options for effective standalone passive CPU coolers, and the SilverStone HE02 is actually the best fanless cooler I've tested that is still in production. The now discontinued no-fan CR95C is even better, but it is not easy to find. As of November 2019, the CR95C is still available at Quiet PC USA or at Fully Silent PCs as part of a complete custom fanless system, while supplies last. The HE02, on the other hand, has wide, long-term availability. In a future video, I plan to test these 4 passive CPU coolers in direct comparison: the Arctic Alpine 12, no-fan CR80EH, SilverStone HE02, and the no-fan CR95C. Hint: They are in this order left to right for a reason. Subscribe to this channel for more fanless PC content. If you or someone close to you is looking for a new silent PC, consider buying it from fullysilentpcs.com. Purchases there help to support this channel and the content shared here. Every sale helps allow me to keep this channel alive and active. Thanks for watching.